Okay, we need to verify the given linear approximation at a equals 0, and then we need to then determine the values for which the linear approximation is accurate within 0.1. So, first of all, my function is 1 plus x to the negative 3, and we want to take its linear approximation at a equals 0, which of course is an x value. First thing I'm going to do is find f of 0 using my formula. And of course, f of 0 is just 1 plus 0 to the negative 3, which is 1. So y1 is 1. So I've got a y-intercept now. Now, to get the slope of my linear approximation, I will take the derivative, f prime of x equals, let's see, negative 3 times 1 plus x, subtract 1 from the exponent gives me negative 4. Take the derivative of the inside, which is just 1. So here is my derivative, and I'm going to plug in 0 for x and simplify this to negative 3. So I've got a point, I've got a slope. My linearization is going to equal m times x minus 0 plus 1, or simply negative 3x plus 1, which does in fact match. Second aspect, I want to determine the values for which this linearization, this linear approximation is accurate to within 0.1 of this function. So this is important. This is my function. This is my linearization of the function. So how do I find this? So I'm going to do this graphically. And the first thing I'm going to do is graph f of x and L of x for you to see. And let me do that real quick here. Oops. And I'm going to show you that. Give me just 1 second. Okay, so I'm going to did that in Desmos, and I've graphed several things here. Okay, so first thing here is, let's just turn this off. This is the original function f, and we said this is its linearization at 0. So if I zoom into the point 0, 1, where I know where they cross, my line and my function should look very similar as I zoom in. Now I want to stay within 0.1, so I took f of x, and I'm going to graph these, and I actually don't have to write the whole graph. Desmos is pretty nice. Let me just zoom out a little bit here. So this is adding 0.1 to f of x. This is subtracting 0.1. Let me zoom out some more. And as long as my my green tangent line stays within these boundaries, I'm good to go. So let's do one at a time. Actually, I'm going to take away the main graph. So I just need to stay in between the purple and the black graph on the green tangent. So this is my tangent line here, and I have to stay within these two graphs, and that as long as I stay, because this is where I intersect. So my lowest x value is this point here. So that's my lowest x value. Just going to write that in here. or just copy and paste that. Don't need it that big. Okay, that's my lower, and actually, I'm sorry, that, yes, my lower x value, and this is my upper x value here. Again, where I'm staying within that plus or minus 0.1 from the original function. So I do that. And so now I have my smallest x value and my largest x value. I'm going to write that x must be in between these two values, negative 0.1162 and in between 0.1441. And that should be the final answer that allows this to be used accurately to represent that within 0.1 accuracy.